Hi everyone, today we are going to talk about SVM or support vector machines. Let's say I have these data points. I have few reds over here and few blues over here. Okay, let's say these are doses, how much dose was given to a particular person and whether they were cured or not. Okay, so let's say this represent not cured, and this is for cured people. Okay, so now simply I can put a line over here and say whoever is on the left side of this decision boundary are not cured, and whoever is on the right hand side is nothing but the cured people, right? Let's say I have these 5 possible options for a decision boundary, and if I ask you which one will you choose, I'm sure you all will go with this middle line. And if I ask you the reason, you'll say that this is far from all the points, right? So in a way, what you have chosen is the boundary which is maximum distant from the nearby points. So this is nothing but called as maximum margin classifier. So what we have just built is maximum margin classifier, where we are trying to fit a decision boundary which gives me maximum margin from the nearby points, and the distance from nearby points is nothing but the margin, right? So we have talked about maximum margin classifier over here. Now let's say I have one data point over here which could be an outlier, and this got populated like this. I'll have to shift my boundary somewhere here, right? So if a new observation comes, let's say somewhere here, then because of this boundary shift I will be assigning them to this red category, but that will be wrong because they are more closer to these blue points than they are to these red points. So in SVM we can allow some misclassification in my data. So I will not shift my boundary because of this point, rather I'm happy to get this observation as misclassified, right? Such that if a new observation comes in, say somewhere here, so I will assign them to the correct class and not to the wrong class, just based on distance, right? So when we allowed misclassification to happen, this is known as soft margin classifier, or support vector class. These points which allow me to define a boundary plus whatever comes inside are known as support vectors. Okay, so till now we have talked about 3 things. One is maximum margin classifier, when we are deciding a boundary where my margin is maximum from the nearby points. Then if I allow misclassification, that is known as soft margin classifier, and the points which help me to decide the decision boundary and the points within this are known as support vectors. Previously when we were talking about that example, it was a one-dimensional data. I had single variable which I termed as doses. So in this case my decision point was nothing but a single quantity, right? But let's say I have this data where I have doses and age which are looking like this. At lower and higher age people have one class, and in the middle age we have different class, right? So I can have a decision boundary over here, which is a line in this case, right? So this is an example how can I divide the data in 2D. Now let's say I have data like this where I have 3 dimensions instead of 2. So I have wages, age and income. So income is on this 3rd dimension. So in order to show it on 2D, I am showing it by size. So the lower the income, they are looking as the higher bubbles. Okay. So in this case, we cannot divide it by line because it's 3 dimension. So what kind of decision boundary can I have? So I can have this plane as a decision boundary, where on top of this plane I have red categories and below this plane I have blue categories. Okay, so in case of 1D we had single point, in case of 2D I had a line, and in case of 3D I have a plane. And if I go beyond 3D, 4D plus, which I cannot draw obviously, those are known as hyperplane. So this is just the terminology. So the point in 1 dimension, line in 2 dimension, plane in 3 dimension, and hyperplane in 4D plus. Now let's say my data looks something like this. These red circles represent people who are cured, and these crosses represent when people were not cured, right? So in this case I do not have any plane, hyperplane or line which can divide my data, right? So this brings us to something known as support vector machines. So we talked about maximum margin classifier, then soft margin classifier or support vector classifier. Now in this case we are going to talk about support vector machine, right? So obviously this is not separable by whatever we have discussed till now. I don't have any points, any line, any plane or hyperplane which kind of divide this data, right? I can find a new dimension, or I can promote this data into a higher dimension. For example, age is square. In this case, let's say this is 0.5 on x-axis. The square axis, it will be 0.25 and so on, right? So this point will come somewhere here, and then this, then this, then this, then I have some points over here. Right. So in this case I will have one line which I can fit somewhere here, to classify reds from these blues. Okay, so this is the idea behind support vector machine, where we see relationship between variables in the higher dimension. Okay, so this is about support vector machines. But how do I do it? Like, how does support vector machine achieve this? So there is something called as kernels in SVM. So kernels is something which makes mathematics possible. So what it essentially does is that we talked about transforming our data into higher dimension, but kernel helps us to understand the relationship in higher dimension without transforming our data. So this is known as kernel trick, where we can identify the relationship between two observations in higher dimension and without even transforming them. Okay, so the most commonly used kernel is polynomial. So we'll see how does it work and how does it help us to see relationship in higher dimension. So this is the formula for polynomial kernel. So this is again a parameter which you can choose. So I have chosen to be 1 by 2 for our case, and let's say I'm talking about second degree polynomial. So this is nothing but I can write it in this format, right? So this gives me, if I expand this, I'll get a square b square plus 2 times 1 by 2 of ab plus 1 by 4, okay, which is essentially a square b square plus ab plus 1 by 4, right, which is essentially okay. So this is the way I can write the same equation. So using dot product, so dot product, what it will do is it will do element wise multiplication. So a square b square and 1 by 4, right? So we see that we have received a relationship in second order polynomial, that too even transforming our data explicitly. So this is known as kernel trick, which makes SVM to work, right? So there is one more kernel called RBF or radial kernel. This calculates this relationship in infinite dimension, right? So that is all possible because of kernels. So kernels is pretty important part of a support vector machine. Next we'll see the mathematics behind SVM in more detail. Thank you.